Right, we're just going to be looking at some of the basic equations that you need to know in chemistry. Some of them you would have come across before, some of them might be new to you. We are also going to look at how to rearrange them and also what units to use them in. Okay, so first things first, we're just going to have a look at this word over here that you hopefully have come across before in chemistry. And that is the term moles, okay, or a mole. And moles in chemistry are basically a way for us to talk about an amount of substance, okay? So moles just essentially means the amount of substance that we have, okay? And if that doesn't really make much sense to you, what we actually mean by that, so sometimes when you're referring to the number 12, you use the term dozen, okay? Chemists do the same thing. We're referring to a very specific number and we use the term moles, okay? And the number that we are referring to when we talk about 1 mole is 6.02 times 10 to the power 23. Okay, so that's a number we refer to when we say 1 mole. Okay, 1 mole of something means the number 6.02 times 10 to the power 23. And this number is a constant, and hopefully you've come across this name before. This is Avogadro's constant. And the notation we use for that is a capital N and a subscript capital A. Okay, this number is given to you, if you don't need to memorize it, it is given to you in the data sheet. So if you just open it up, I'll show you. It's the second number given there. Okay, so that number is given to you on the data sheet. And what that does is, if we've got the moles of something, or if we've got a value for the number of moles, we can basically work out how many particles or how many atoms we are actually referring to. Okay, so the first equation that we're going to look at is the one where we calculate the number of particles using Avogadro's constant. Okay, I'm going to do everything in the triangle form, so all the equations I'm going to do are going to be written in this kind of triangular notation. The reason being is because it's easy to rearrange if you use the triangle notation. Okay, so if we're calculating the number of particles, all we do is we do the moles, the number of moles that we have, multiplied by Avogadro's constant. So if I have 1 mole of a substance, so if I have 1 mole of copper atoms, all I do is 1 times Avogadro's constant, which is just going to give me Avogadro's constant, and that tells me I have 6.02 times 10 to the power 23 number of copper atoms. Okay, and as you can see, if it's in the triangular form, it's easily rearranged. If we're trying to work out the number of moles, if we've been given the number of particles, all we do is we cover up the bit we're actually trying to work out. So we're trying to work out moles. So moles equals number of particles divided by Avogadro's constant. Okay, so everything I'll do is in that triangular form there. Okay. Right, so that one's fairly straightforward, calculating the number of particles in a substance. Let's move on to calculating the number of moles in a solid. Okay, so this equation here will apply to solids. And again, hopefully this is an equation you've come across before. Again, I'm going to do it in triangular form. It is mass divided by the moles multiplied by molar mass. Okay, so that's molar mass over here. You may have used it referring to the term relative formula mass, and they all mean the same thing. The relative formula mass, the molar mass, is calculated by the sum of the atomic masses in the compound. Okay, so for example, if you have H2O, it is 2 times 1, which is the atomic mass of hydrogen, plus 16, which is the atomic mass of oxygen. So it's 2 lots of hydrogen because it's H2O, and the relative formula mass, or the molar mass, of water is therefore just 18. Okay. In chemistry, the mass should always be in grams. Okay, so make sure when you are using this equation here, your mass is in grams. And again, if you're trying to work out the moles of a solid, it is just mass divided by molar mass. If you're trying to work out the mass, it is moles times molar mass, and so on. Okay, so that one should be fairly straightforward. So you're usually working out the mass of solids or you use this equation when you're referring to a solid compound. Okay, right, let's move on to gases. Let's cover gases now. Okay. So with gases, I'm going to be just referring to room temperature and pressure. Okay, so this over here is just going to be the equation at room temperature and pressure. So RTP just means room temperature and pressure. And for this one, I'm just going to draw out the triangle. Okay, so this one over here is volume, because gases we're referring to the volume. We don't really look at the masses of gases. So we refer to the volume, and that is the number 24 multiplied by the moles. Okay, now this 24 over here, we are referring to the molar gas volume. Okay, and I'll explain in a second what that means. This number, this 24 number, is given to you in the data sheet. So again, if I just open up the data sheet in front of you, it's this number at the top over here, the molar gas volume, 24 decimeters cubed per mole at room temperature and pressure. Okay. So that is basically saying that if a gas is at room temperature and pressure, it is going to be occupying 24 decimeters cubed. Okay. So the volume here, as you might have guessed it, should be in decimeters cubed. Okay. If it's not in decimeters cubed, now this is important. If it's not in decimeters cubed, what you can do, wrong one. If it is given to you in centimeters cubed, you should be comfortable with this conversion. So centimeters cubed to decimeters cubed, you just divide by 1,000. Okay. Or what you can do is use a different equation. And that is where the volume is already in centimeters cubed. All that changes in this equation is that this number here is not 24, it's 24,000, which is essentially just the same as dividing it by 1,000 as well. Okay, so if your volume is in centimeters cubed, your molar gas volume is 24,000 decimeters per mole, decimeters cubed per mole. Okay. So you can use this equation to calculate the moles or the volume of any gas at room temperature and pressure. Okay, if it's not at room temperature and pressure, we're going to move on to much later another equation that we can use. Okay, right, let's now have a look at calculating the moles in a solution. So a solution, so like an aqueous solution where we have dissolved a substance in water. Okay, the equation that applies for this is moles over concentration times volume. Okay, now in this equation, in chemistry, the units for concentration are moles per decimeter cubed, which I've notated like that. Okay, at school you may have looked at it in this form, so moles / decimeters cubed. Okay, that means the same thing. That dash there just means it's a divide sign, so it just means divide. So it's just the same as moles divided by decimeters cubed. And if we now just do a bit of maths on this, bring decimeters cubed to the top means making the power negative, which is therefore this notation here. Okay, so all of these, so this one here, and this one here, they mean the same thing, but this is the one that we use in chemistry, moles decimeters to the -3. Okay, if your concentration is moles per decimeters cubed, that means your volume must also be in decimeters cubed. If it is not, remember, converting between centimeters cubed to decimeters cubed is just dividing by 1,000. Okay, so this is the equation that you would use if you want to calculate the concentration or the volume or the moles of something that has been dissolved in water. Okay, so again, if you're trying to work out the volume, it is moles divided by concentration, and so on. Okay. And as you can see in all these equations that we've covered, whether it be for working out number of particles, whether it be for, the one for a solid, a gas, or a solution, they all have the term moles in it. Okay, so as you can see, moles is kind of like the universal currency that we use in chemistry. Everything can be converted into moles, and then you can then use that value in another equation. Okay, so moles are universal currency. You should be very comfortable in converting literally any calculation, any kind of values that you get, any variables that you get into moles. Okay, so have a look. Is that substance a gas? Is it a solid? Is it a solution? And from there, that should hopefully tell you which equation to use out of the four that we have just covered.